Good morning, everybody. Now let us see about the common emitter amplifier analysis using small signal hybrid model. Generally, we have two types of transistors, NPN and PNP transistors. Now let us consider only NPN transistor. Okay, this is a general NPN transistor. So this is the small signal equivalent circuit for NPN transistor. So we have the resistance R pi. Since this is the hybrid pi model, we have the R pi, and here we have the current GM into VBE, and we have the base current, emitter current, and collector current. So this is the voltage across base and emitter. This is the voltage across collector and emitter. The small signal input base current is related to the signal input voltage. So VBE, what is VBE? V is equal to I into R. So VBE is I into R. So here we have the base current into the resistance R pi. So what is R pi? So R pi is known as diffusion resistance. R pi is equal to VBE by IB. So now we know that the transconductance is denoted by Gm. Gm is equal to beta by R pi. So we have already found the value of R pi. What is R pi? R pi is VBE by the base current IB. So here we have beta into IB by VBE. So we know that IB equal to IC by beta, or IC is equal to beta into IB. So here Gm, transconductance, equal to beta, and substitute the value of VBE by beta into IB. So I get Gm is equal to IC by VBE. So let me consider this voltage as a total voltage VT. So if I calculate the gain, current gain AI, so I know the value Gm. Gm is conductance, so here I have I by V. Resistance is V by I. So voltage across base and emitter, voltage across base and emitter is getting cancelled. I get the value IC by IB. So IC by IB is beta. I know that the current gain AI is Gm into R pi. So beta is Gm into R pi. Now let us go into the common emitter analysis. Analysis of common emitter amplifier. Now, first let us consider the bypass configuration. So here I have transistor, NPN transistor. I have the resistance, collector resistance. I have the voltage bias resistance R1, R2, source resistance RS, input and output capacitance C1, C2, and the bypass resistance and capacitance RE and CE. So as we are giving the bypass, the amount of voltage is being bypassed here. So here it provides the low resistance path to the amplified signal. So if I don't have this CE and RE, or if I don't have the capacitance inserted in parallel to the resistance RE, the drop across it will be very large, and we should consider the value of RE in order to find the value. So since I have bypassed, so this will reduce the output voltage, so thereby it reduces the gain. So let me see the equivalent circuit of the CE amplifier. I have source resistance, source voltage. I have R1 parallel to R2 base resistance. I have the equivalent circuit of the transistor. Output I have internal resistance R0 and collector resistance RC. So here input resistance Ri. So I can take this both resistance Rb and Rpi as my input resistance Ri. I know that Rb is base resistance R1 parallel to R2, which is in turn parallel with Rpi. So what about the output resistance? I have R0 in parallel to Rc. So the gain is output by input, output voltage to input voltage as it is voltage gain. So what is my V0? V0 is equal to I into R. So what is my I here? So total current is Gm into V pi. I into R. R is the R0 here. R0 is small, R0 parallel to RC. Since the current is in opposite direction, I just make my value as negative. So what is V pi here? So by using the voltage divider rule, V pi is total voltage Vs into same side resistance by the total resistance. So the total voltage I am considering it as Vs. Same side I have the resistance Ri and total resistance. Now substitute this value of V pi in my equation number 4. So I get the value of V0. Now substitute the value of gain. Gain is equal to output by input. So consider this as my output voltage and this is my input voltage. So Vs values will getting cancelled and then I have the remaining values. Voltage gain is equal to minus Gm into R0 parallel to Rc into Ri by Ri plus Rs. So similarly, if I consider the bypass circuit, the unbypassed circuit, so if what is unbypassed? I have not bypassed the value of capacitance here. So there will be a voltage drop here. So I need to consider the value of Re. So look on to the equivalent circuit. So I have my voltage source, resistance, R1 parallel to R2 base resistance, R pi and Gm into R pi. So here Gm into V pi. Consider this as the equivalent circuit of transistor and here I have considered Re. So this is Re and the collector resistance Rc. So here I have considered this as Ri, I have considered this as Ri dash. So what is Ri dash? Rb. Rb in parallel to Ri dash. Both this will be considered as Ri. So what is Ri? Rb in parallel to Ri dash is Ri. I know that Rb is R1 parallel to R2. My output resistance is collector resistance Rc. Output resistance, collector resistance Rc. Now I have to calculate the gain V0 by Vs. So now I am going to break my output. I am going to consider an voltage Vi. So I am going to multiply and divide by Vi. So here this is my Vi. So V out by Vi into Vi by Vs. So I am going to break the circuit. So what is V0 by Vi? So I know that output V0 is I0 into R0. So I0 and IC are in the same direction. So I0 I can consider it as IC. So since this is a leaving current, I0 plus IC is equal to 0. So I0 is equal to minus IC. So what is my V0? V0 is, I know that IC is equal to beta into IB into RC. And input voltage Vi is IB current into Ri dash. And what is my Vi? So according to the voltage divider rule, I know that total voltage is Vs into Ri by Ri plus Rs, as we have seen earlier. So Vi by Vs is Ri by Ri plus Rs. Now consider all these equations and substitute in the voltage gain. Substitute in the voltage gain equation. So I know that voltage gain V naught by Vi. Now what is V naught? V naught is minus beta into IB into RC. That is V naught. What is my Vi? IB into Ri dash into Vi by Vs. Consider this whole equation. Substituting the value of Ri dash, we get AV is equal to voltage gain is equal to minus beta into RC by Ri dash value into Ri by Ri plus Rs. Now consider Ri value is greater when compared to Rs, and the second term 1 plus beta into Re, beta is greater when compared to R5. So I get voltage gain is minus beta into RC by Re plus beta into Re. So if Re value is very small when compared to beta into Re, so the gain is nearly equal to minus Rc by Re. So the voltage gain value increases by selecting the Re value very small. This is about the analysis of common emitter amplifier in the bypass and the unbypass circuit. Thank you.